Hi, I'm John, this is Victor, and this is Aryav, and we're from the 16460 GEarheads from Brookfield, Wisconsin. We're thrilled today to discuss the improvements that we've made to our robot in 30 hours build. Our first major improvement was our hopper mechanism, which stores the game pieces. It was formerly made out of cardboard, now it's much more robust, made out of cut aluminum. We had to make some slight modifications as well to allow for our claw, which we now have attached, to be able to function and move upwards with a game piece in order to deposit it directly into the hopper. Then we have this paddle, which then tilts upwards into this sort of flywheel-like system, which just uses two wheels to launch it at high speed. These spin up ahead of time so that we don't need to wait for them while they're spinning up, and so it's more consistent, which we found to work pretty consistently most of the time. So we can now talk about the improvements that we hope to make in the future for our robots.
Yeah, so some of the improvements we're planning to make is, first of all, we noticed that a claw is a little slower, so we were thinking of adding an active intake with probably rollers as some of the other bots are doing. And then we also plan to probably make our trade-off between the intake and the outtake a little bit smoother. Right now, it's sometimes get a little caught, and then sometimes just have a little bit of issues with the plate and it still being up and stuff like that. Yeah, that we'll figure out. And then we also plan to just overall improve like software and like use a lot of presets. So, because like one thing we noticed was like the aiming. That's a little bit tricky, and sometimes we are a little too far to the right or left, so we just need to perfect that and get that down. But yeah, and then now we can talk about the software.
Yeah, I want to highlight a few points on our software-wise. So first of all, the way we design the system is by subsystem. So in our main robot, we have three main subsystems. We have a drivetrain, which is basically these four wheels over here. And on the drivetrain, we have FOV, which allows our driver to sync up the view on them instead of on the robot. And then we have this intake system, where essentially we have the servo and the motor to lift it up. And then we have this outtake system, where we have a flap to push the artifact up. And then we have these two motors to spin the ball out. And we use a lot of different mechanisms here. And one of the things we use to simplify driving is state machine. We actually have two separate state machines here. We have the intake state machine, where we do the claw grabbing position up and drop in one button. And we also have this outtake state machine, where we have the ball, where we push the ball up, and then having it spin out in one button. So by doing that, we simplify driving a lot, and which allows our driver to focus more on the locationing of the ball. And we also have a motor encoder-based autonomous, where we essentially just go forward, backward, straight, left, right, and then turning to certain degrees. And that has allowed us to do basic autonomous in 30-hour build, and that's our goal for this event.
Thank you for watching, and if you want to see any more videos about the 30-hour build, check out Fun's YouTube channel.